geopolymer concrete, as well as at present I'm working on DST project, which is on recycled aggregate concrete. So, but I thought of selecting this topic for this particular FTP program because this is relatively new, and if you see the literatures on this particular area, so we can see only a minimum amount of literature on this particular topic. So I thought like it would be useful for the participants, especially those who have an idea of taking up the research work or a doctoral program. So they can consider this as a research topic if they have some interest on this particular area. So my presentation actually, so I will go on these lines. So basic introduction about this topic and how this system, that is demountable building systems, have been developed. And in my presentation, I'm particularly going to focus on the building systems. So even though I've given a topic in a general way, so in this particular lecture, I'm going to focus only on the building systems. So I'm going to give you some brief introduction about the demountable precast RC frame systems and how these frame systems can be effective for resisting the lateral forces. So that also I'll be covering a little bit. And also what are the merits and advantages, and also the demerits or the challenges we have when we are going to implement this practically for the real-time applications. So that also I'm going to mention in my presentation. And of course, see, I have not done any work related to this topic, but I have referred some of the literatures, and I've given at the end of my presentation the references which I have referred for preparing this PowerPoint presentation also, which will be useful for you in future. So what is this demountable RC structure? So this is different from a conventional or a traditional reinforced concrete frame building. So at the present scenario, actually the conventional buildings, that is RC frame buildings, and also the existing precast frame systems, so they are actually fully monolithic system or partially monolithic system. So this is the present scenario with respect to the building frame systems. So, so we have the monolithic construction, and the connection between the individual elements in the building system is achieved either through wet joints or partially dry joints. So this is the scenario what we have in the conventional building frame system. So even in the precast system, so we go for only partially dry connections between the individual elements. So what is this demountable RC building is about? Okay, so and these have several drawbacks where when we take the conventional RC building frame systems, so we have several drawbacks. For example, if few elements are irreparably damaged, then in that case, so we have to demolish the entire building. So that is the issue what we have now. And even in case of earthquakes, suppose if some minor damages are have occurred because of the seismic excitations, so even if the level of the damage is moderate or repairable, so buildings using these systems, inevitably they are incurring a huge loss. So because of the downtime and repair cost, which is required to fully restore the functionality of the damaged building. So for this reason, actually several researchers, they are exploring different options, especially they are looking for alternate building systems so that are quickly or easily repairable and minimize the downtime and other seismic losses. And also if we take the life of a building, so the usage of a building can constantly change also, because if the same building it is to be used for a different purpose than it was originally designed for, so the current building may not satisfy the seismic design demand corresponding to the new function. Therefore, the existing building needs to be strengthened to cater for the increased demand. So these are the so with this background, so this idea has been developed actually, that is demountable RC structure. So this is nothing but actually a prefabricated system, so in which the different components or the parts of the building, so they are assembled by properly designed and fully removable dry structural connections with no or almost no cast in place concrete. So this is the basic definition of this demountable RC structure. So this is a prefabricated system, so which is where the structural parts are assembled with the help of the dry structural connections. So in this particular system, so we can demount the structure very easily with no or little destruction. And so instead of going for demolition, so we can go for this demounting in this particular system. So thereby leading to the less energy consumption, so better cost control, and quality management also can be better. And also we can minimize a lot of pollution such as dust and noise pollution also. But as far as this demountable precast system is concerned, so even though some researches have happened in this particular area, as far as the practical application is concerned, it is very much limited. So because of the lack of knowledge and also because of the lack of standards also, we can say. So this particular application of this demountable RC structure is very much limited now. And also because of the lack of the physical testing facilities also, as of now, the practical applicability of this demountable RC system is very much minimal. So if we see there is a possibility to reuse the structural components as elements for new buildings, either in the original shape or they could be adjusted for the new geometries also. And there is a possibility of upgradation of the building system also in the seismic regions. So we can replace the critical elements, or we can with the new elements of higher strength. So that is also possible with respect to demountable building systems. And easily we can add some extra elements, for example, steel braces to the lateral load resisting frames. So these are some of the advantages we have in this particular demountable RC structure. So how this has been evolved, how this idea has been evolved. Actually, this idea has been evolved based on a philosophy of a next generation building system. Actually, so this the concept of this next generation building system is that to achieve the sustainable buildings. So the basic philosophy of this next generation building system is to build the buildings in a short time, in a flexible manner, so that we can accommodate the changes in functionality and can be dismantled and reused rather than demolished. So this is the basic principle of this demountable building system. And as far as the development of this demountable building system is concerned, actually this system was first developed by Reinhardt in the year 1976. And thereafter, actually many systems were developed by the Dutch companies in the year 1996. And as of now, actually several systems are available in the market as listed in the slide. So we have some MXB5 system, CD20 system, SMT system, Westcon 30 system, and Moducon 2000 system, etc. So this is about the development of systems. So this is not a new thing which has been developed long ago in the year 1976 itself. And this is a typical actual demountable precast concrete frame building system. So which is proposed by Ananta Neni and R.P. Dakal. So as far as this system is concerned, so we have the conventional frame system with beams, columns, as well as we have a slab system, etc. So here the load resisting elements of this proposed system are very similar to the conventional frame system. So we have some perimeter frames. So we have perimeter frames. And also we have the internal frames. So the internal frames are normally designed for resisting the gravity loads like the dead load and the live load, whereas the perimeter frames are designed for resisting the lateral forces which are caused by the winds or earthquake forces. So it is similar to a conventional building system, so where we have the perimeter frames, internal frames, and also we have the connections, beam column connections. And in addition to that, as I said, there is the upgradation possible in this particular system. So suppose if we want to increase the lateral load resisting capacity of the system, so we can add the braces to the existing system very easily in the case of demountable precast concrete frame structural system. So steel braces can be easily added, so either as a part of the initial design or as an upgrade to an existing demountable buildings in order to increase the load resisting capacity. So this is the main advantage of this demountable precast concrete frame system. And normally, the perimeter frames, the connections are made very rigid, whereas the internal connections are made as shear connections. Because as I said earlier, these perimeter frames, they will resist the lateral loads also, whereas the internal frames are designed for resisting the shear forces or axial forces. So now we are going to see the different types of connections because this demountable precast RC frame system is concerned. So the main thing is the connection between the individual members, so which plays an important role or crucial role in resisting the lateral forces. So these types of connections are possible in the demountable precast RC frame systems. The first one is the floor to floor connection. And the second one, we're going to see what is the floor to beam connection, and beam to column connections, then column to column connections, then column to foundation connections. So this is a typical floor to floor connection. So here for this demountable floor to floor connection system, so any type of floor can be accommodated. For example, if it is a flat floor or ribbed floors or hollow core slabs or even T-shaped slabs. So any types of slab can be accommodated here in the case of in the proposed demountable system. So we can go for flat slab, or we can go for ribbed slab also, or we can go for hollow core slab also as shown here, or we can go for T-shaped slab also. So here the main thing is that the connection is made with the help of steel plates as shown here, and also the pre-tension bolts. So as far as the inertial forces are concerned, so they are transferred to the perimeter frames, so through the floors, so which act as the rigid diaphragms. So that is the load transfer mechanism. So here the inertial forces are transmitted to the perimeter frames through the slabs, and the connections are achieved with the help of the steel plates and the pre-tension bolts. And so we have the friction which is developed between the steel plate and the slab. So that frictional force will take care of the longitudinal shear that is there between the longitudinal shear is taken care by the connection between the steel plate and the slab. And after the slip, once the slip occurs, the resistance will be given through the double action after the slip. So this is the load transfer mechanism for the floor to floor connection. So here for resisting the longitudinal shear, so the frictional force comes into picture, and after that the double action also comes into picture for resisting the longitudinal shear. So this is again the floor to floor connection. So here you can see the steel plates, then we have the bolts. So this is the floor slab, and in order to hide this connection, in fact we will level the slab with easily removable sleeve to hide the connections. And sometimes the slabs are connected together by because the slabs will have some projected ends, and the one slab will be connected to the other slab like this. So we have some sawtooth arrangement so that the two adjacent slabs can be actually fit into the nearby slab. And this is another type of floor to floor connection. So this is before assembly and this is after assembly. So we are connecting the slab segments with the help of top steel plate as well as the bottom steel plate, and which are connected together with the help of high tensile threaded steel boards. So this is one of the arrangement for the floor to floor connection. And we have another arrangement also, which I will show you in the next slide. So this is actually another type of floor to floor connection. So we have some embedded steel blocks here, so with ribs, and which is welded to the steel reinforcement here. So this is before assembly, then this is after assembly. So we have some embedded steel blocks which are welded to the steel reinforcement in tension at the bottom of the slabs. So here the problem is that sometimes we have the premature failure of the steel blocks because of the stress concentration at the edges of the blocks. So this is the one of the problems we have in this particular type of connection when we have the embedded steel blocks in the connection. So this is one type of connection where we don't have the embedded steel blocks. Whereas here, so we have, in addition to the steel plates on the threaded bolts, so we have the embedded steel blocks with the ribs, so which help in the connection of the two floors. And this is a typical floor and that is slab to beam connection. So here we have, so as I said, from the floor, the lateral load will be transferred to the perimeter frame through the floor to beam connection. And here also we are using the steel plates, and also we use the stiffened angles and the bolts for the connecting the floor and the beam. So here, if you see the bolted connection, so the bolts which are connected to the floor slab, they are removable actually, whereas the bolts which are connected to the beam are embedded. So this is the type of arrangement what we have in this particular floor beam connection. So it is a simple connection only, where the connection is achieved with the help of steel plates, stiffened angles, and the bolts. And again, if you can see here, so we have threaded sleeves, so which were embedded into the beam and the floor slab also. So it is provided with the ducts actually. The floor slab is provided with the ducts. So we have threaded sleeves which were embedded into the beam, and the floor slabs are provided with the ducts. And the bolts, they normally pass through the ducts into the floor slab and clamp to the embedded sleeves in the beam. So this is the arrangement normally we have in this floor to beam connection. So, and here the size of the connection as well as the spacing of the connections, so that has to be designed in such a way that it will transfer all the loads from the floor slab to the beam. So this is the load transfer mechanism in this particular type of connection. So here the connection is achieved with the help of threaded sleeves which provided with ducts, and we have the bolts which pass through the ducts into the floor slab, and it is clamped to the beam through the embedded sleeves. So this is the connection between the floor and the beam. And coming to the beam column connections, so this beam column connection is very, very important because the efficiency of the frame, any frame in resisting the gravity loads as well as the lateral forces, it depends mainly on this beam column connection. So the beam column connection should be designed with proper care so that all the design forces or forces are transferred in a proper way to maintain the strength as well as the stability of the system. So here, two types of connections are possible. One is the shear connection. Another one is the moment connection. So as we know very well, the shear connections, they will transfer only the shear forces and the axial forces. Whereas the moment connections, they will be having the capability to transfer the bending moment as well to the connecting members. So that is the difference between your shear connections and the moment connections. So as I mentioned earlier, so we have the perimeter frames as well as we have the internal frames. Normally the perimeter frames, we will have the rigid beam column joints, whereas the internal frames will have either shear joints, or we can say shear or pin beam column joints. So these are the two types of connections normally we have in the beam column connections. So this is one of the beam column connection, and this is a moment connection. So here we employ the steel end plates and the threaded rods. So here we have end plates. So we have threaded rods also. So this is one of the beam column connection, and this is a moment connection. So here we achieve the connection with the help of end plates, and also we have two steel plates which are embedded into the concrete beam. And here the main thing is that, so the beam reinforcement is normally welded to the embedded steel plates. So before casting, and also the end plate is connected to the precast column using the threaded rods. So here the performance is mainly dependent on the transfer of the force from the beam in the rebar to the embedded steel plate. So this has been found to be very effective in this particular type of connection. So this is another type of connection, again the moment connection. So here we can see this is a corner joint, and this is the internal joint. So this is how the connection will be. So here we have the gusset plates also for the connection. So we have angles and we have the gusset plates. So this is for the interior joint and this is for the corner joint. So the connection is achieved through with the help of gusset plates, angles, and the high strength friction grip bolts. So this is again, so there are certain design parameters actually. So normally the bolts, what we are using for the connection, so they are pre-tensioned, so we have some frictional resistance developed between the steel connection or steel connection and the precast concrete elements. So this frictional force actually developed, it will resist the forces which are transferred. And here, so since this bolts are pre-tensioned, so the amount of the pre-tension in the bolts is based on several parameters like the grade of concrete, then grade of fill material, if any, between the connection and the precast concrete elements, and the grade of the threaded rods or the bolts. So this is, you can see the connection here. So where you have the beam reinforcement and you have the angles, we have the gusset plate. And here you have a plate at the column. So these two are connected together with the help of the threaded bolts. So we have initially some pre-tension in the bolts, which will take care of the forces through the frictional resistance. And sometimes the gap between the beam and column, so we can grout it, we can have the grout to cover it, so we can fill the using the grout material. So we can see the gap between the beam and the column. So these gaps are filled with the help of the grout on the beam surfaces. And coming to the load transfer mechanism in this particular case, so these are the forces which are developed. So we have moment, shear, and we have the axial force. And this is actually before the slip between the connection and the beam. So we have the tensile force. So this tensile force is developed either in the longitudinal bars, or the tensile force is developed in the bolt also, or in the bolt or in the horizontal stirrups also. And as far as the compressive force is concerned, so we have either in the internal stress block, or we have the compressive force developed in the column, or due to the bearing of the connection also, we have the compressive force which is developed, or we have, due to the bearing of the bolts, we have the compressive force developed. And of course, we have the frictional force between the connection and the beam due to bending moment. And you have the shear resistance between the connection and the column also. So these are so as far as the load transfer mechanism is concerned, so all these forces come into picture. And the main thing is the frictional resistance between the connection and the beam due to the bending moment. So this is particularly before the slip between the connection and the beam. So here, only two things are possible. One is that if the frictional force developed is higher than the horizontal interface force, then there is no slip between the connection and the members. So your frictional resistance should be higher than the horizontal interfacial force. So in that case, there is no slip. So if that is the case, then the behavior will be very similar to the conventional precast concrete frame that uses the wet joints. So here the failure can happen either due to the yielding of the steel or the cracking of the concrete. So this is a no slip case. So this is when the frictional resistance developed is more than the horizontal interfacial force. So here we have the conventional type of failure. Either the joint will fail by the yielding of the reinforcement or the cracking. Now there is another case when there is some pre-tension force in the bolt. So if there is a reduction in the pre-tension in the bolts, so we have some reduced frictional resistance. So FR. So this FR is nothing but the reduced frictional resistance. So because of this, there is a loss of contact area due to spalling of concrete. So when this happens, so definitely the induced forces will be more than the frictional resistance. Therefore, behavior of the connection here, it is a combination of slip as well as the conventional failure. So you have Is my PPT visible? Sure. Connection prediction. So my PPT is visible now.
Yes, ma'am.
Yes. So we have two possible conditions, either like before the slip, how the behavior will be and how the load transfer will be, and after the slip, how the load transfer will be. So here the capacity of the connection is the minimum of these three thing. Either it is the moment capacity of the beam or it is the capacity of the connection. So the capacity of the connection, it is again either shear or bearing or tensile capacity of the bolts and the steel elements of the connection, or any other possible mode of failure, that is concrete edge breakout in shear. So these are the different types of failures, and their capacity is finally is going to be the minimum of these three things. And coming to the governing design parameters for the beam column moment connections, that is using stiffened angles as well as the bolt. So there are certain guidelines for us. So the amount of the pretension in the bolts, it should be limited to 70% of its tensile yield capacity. So that is one of the design parameter. And the grade of concrete is also the compressive stress induced by the pretension has to be less than 25% of the concrete strength. Because as we know, because of the pretensioning of the bolts, certain amount of the compressive stress will be induced, and therefore the grade of concrete has to meet out that. So because of that, the design consideration is that the compressive stress induced by the pretension has to be less than 25% of the concrete strength. And there is a design guideline for the amount of the pretension which is applied to the bolts also, that is connecting the connection as well as the beam. And there is a limitation for that also. So the amount of the pretension in the bolt should be such that the slip is avoided until the beam reaches 2/3 of its yield moment capacity. So that is one of the main design parameter. So we have to provide the amount of the pretension in such a way that, so we are avoiding the slip until the beam reaches the 2/3 of its yield moment capacity. And on the column side, so the amount of the pretension in the bolt is such that the vertical slip due to the shear force induced at the ultimate stage of loading is minimal. So on the column side, we have to take care of this also regarding the amount of the pretension to be applied on the bolts in order to avoid the vertical slip. So this is the second type of beam column moment connection. So the first type, what we have seen is use of the stiffened angles on the gusset plate along with the high strength friction grip bolt. And this is the first connection what we have seen, simply using the steel end plates for the connection with the help of high tension bolts. And the second connection what we have seen is with the help of stiffened angles with the gusset plate as well as the high strength friction grip bolt. And this is the third one, that is here we are using stiffened angles as well as steel tubes. So we have steel tubular connection here along with the high strength friction grip bolt. Again, this is for the corner frame and this is for the interior frame. So in addition to the, so here we have the steel plates additionally in the sides also. So that is the difference between the previous connection and this connection. So it is here in the form of a tube where we have additionally plates on the sides also. Now coming to the shear connections. So here, if you see the connection between the beam on the column, so we have some embedded plates like this. So we have embedded web plates with holes, in fact slotted holes. and they're connected to each other using the high strength friction grip bolt. So as we have mentioned earlier, so this type of connection is capable of resisting only shear and axial forces and not the bending moment. So this is also one type of connection where we can employ this type of connection for the interior frames. So not the perimeter frames, because the perimeter frames have to withstand the lateral forces also, where the bending moment also will come into picture. Whereas if this shear connection is concerned, so it is capable of resisting the axial forces and shear forces which are coming into picture. So this is a close-up view of the beam column connection. So you can understand from this picture clearly how the dry connection is achieved between the concrete beam as well as the concrete column with the help of the embedded steel plates. So here you can see these two steel plates here. So one connected with the column and the another one which is connected with the beam. And one interesting thing what we can note here is that, so here the horizontal reinforcement that is of the beam is welded to the steel plate. So this is the speciality of this beam column connection. So this is a shear type of connection. And also if you can see here, so this is the column rider plate. So you can see here, so here we have the bolts to accommodate the bolts. So it is connected together with the help of the bolt. So this is one type of beam column connection, which is a shear type of the connection. So for the beams and columns, you can see the conventional reinforcement. And other than that, for the connection, so we have the rider plates, and this is the beam end plate. And the longitudinal reinforcement of the beam is welded to this steel plate. So this is the beam column connection, that is pin type of connection, what we can have for the system. And another type of shear connection is that by providing the mechanical pins like this. So here also we can see the beams and columns, they have the embedded steel plates. So here also we have the steel plate here. In the column also we have the steel plates, and they are connected using the high strength steel pins. So here the main thing is that we ensure through this type of connection is that the lateral loads are resisted only by the seismic frames or the perimeter frames or the lateral load resisting frames. So this type of connection is using mechanical pins. So here we can see here, this is the gravity load resisting beam. So the connection is achieved with the help of the mechanical pins. And the next type of connection is column to column connection. So here also we are using the steel end plates. So these steel end plates are embedded within the column dimensions. You can see here, so these plates are within the column dimensions at the ends of the columns. And at the column ends, we have some recess to accommodate the bolts. And the columns are connected with the help of the high strength friction grip bolts. And this type of connection, we also call it as steel shoe splice connection. And this type of connection is very much capable of transferring the tensile forces as well as the bending moment. So this is one type of connection. So where you can see the steel end plates which are embedded within the column dimensions. So there is one more type of connection that I will present in the next slide. So where you can see the steel end plates at the column ends. So here also we have the steel end plates at the column ends. But we can see the dimensions of the plates are bigger than the column dimensions. And here the holes are outside the column. And again, we can have, we are employing high strength friction grip bolts for connections. And here, this type of connection is capable of transferring axial forces, shear forces, as well as moments through the bearing resistance of the steel plates and the tensile resistance of the bolts. So this is how the load is resisted. So either through the bearing action or bearing resistance of the plates or through the tensile resistance of the bolts. So you can see the difference between these two connections. So here, we have the steel plates embedded within the column dimensions, where here steel end plates are having higher dimensions or bigger dimensions than the column dimensions. So which is capable of resisting axial as well as the shear and the bending moment. And this is the column to foundation connection. So it is also very similar to the column to column connection. So where we have the steel plates, so embedded within the column dimensions like this at the end of the column, or steel end plates or bigger than the column cross section. Whereas here, so here we have two type of connections. So one is the steel plates are embedded within the column dimension, similar to your column to column connection. So here you can see the steel end plates are bigger than the column cross section. So this is the type of connection between the column and the foundation. So this is a fixed connection. And as usual, here also we employ the steel plates and the bolts for the connection. And similarly, we can have the pin type of connection also for the column to foundation connections. So we can employ the bidirectional mechanical pins. So to connect the column and the foundation. So this will allow the free rotation under the lateral forces. So that is main important thing since we are employing mechanical pins. So it will allow the rotation under the lateral forces. And so here in this case, these type of connections can be employed in the gravity load resisting frames to transfer the shear and axial forces, and also used in the column bases of lateral load resisting frames to avoid the otherwise inevitable damage during the earthquakes. Normally, these type of mechanical pin connections are employed in the case of lateral load resisting frames, especially at the column bases. So that also we will see in the subsequent slides. So how in the frames these connections will be employed and what are the different connections which are used for the lateral load resistance of the frames. So now we are going to see these three different types of RC precast frame systems, especially for resisting the lateral forces. So these three types of connections are possible. That is, these three frame systems are possible. The first one is the unbraced frame with the fixed bases. And the second one is we have the braced frame with pin bases. So pin or rigid beam column connections. And third one is we have the unbraced frame with the pin bases. So these are the normally employed frame systems, precast frame systems for the lateral loads. So this is the frame with the fixed base. So here you can see the location of the plastic hinges, especially when you have the frames with the fixed base. So here you can see the damages in the ground story columns also, where you have the formation of the plastic hinges. So here, this type of frames will resist the lateral forces by the developing bending moments. So this particular type of system is, in general, they have greater strength and stiffness and robustness when compared to the other systems. And these are the plastic hinges which are developed. So because of the lateral forces. So, and you can see the ground story columns also will have the damages will be there in the ground story columns also under the design level earthquakes. So this is the behavior of the frames with the fixed base. Whereas you can see here the frames with the pinned base. So here there is no plastic hinge formation, especially at the ground floor. And additionally, we are employing the steel braces in this system. So when you employ the steel braces, actually, so the resistance is developed both by the flexural resistance of the frame as well as by the axial resistance of the braces. So here the damage is limited only to the beams, as I said. So provided we ensure the weak beam, strong column hierarchy. So if that is ensured, in this particular case, the damage will be restricted only in the case of beams. And additionally, if we provide the braces, the resistance will be developed by the axial resistance of the braces also, in addition to the flexural resistance, which is provided by the beams and the columns. So that is the load transfer mechanism in the case of frames with a pinned base. So here, in this case, so we don't have the braces. So we have simply frame with pinned base. And as I said, the lateral load resistance will be developed by the flexural resistance of the frame elements. So you will have the development of the bending moments, both in the case of beams as well as in the case of columns. So here, if you have the braces, so with the pin connections, it is between the beam and the columns. So here the load transfer is mainly through the strut and tie action, which is provided by the braces. So normally when we employ the braces, the load transfer is through the strut and tie action. As we know very well, the concept is very clear, especially when you employ the braces. So it will, the load transfer will take place through the strut and tie action. So this is the comparison of the performance of the frames with the different support conditions. So we have frame with fixed base, when we have frame with pin base and brace, and when we have the frame with pin base. So this is, you can see the behavior of these systems. So this, especially this increases because of the addition of the braces, steel braces to the system. Otherwise, if you have simply with frame with pin base, so this is the behavior. So your base shear capacity is less when compared to the frame with the fixed base. So overall, as far as the strength and stiffness is concerned, the frame with the fixed base is always better when compared to the other two load resisting systems based on the boundary conditions we provide. And this demountable system is completely a dry connection system. So where either we can go for full dry connection, or some cases we provide some partial dry connection. We use some cast in place concrete to ensure the connection. Otherwise, in the case of demountable systems, it is a completely a dry connection. And as I mentioned in the first few slides, so we have several advantages. So normally the conventional systems, that is traditional frame systems, as well as the existing precast concrete systems, so they don't account for the deconstruction. Whereas this demountable concrete system, it accounts for both construction as well as the deconstruction. So if you have any damages in the system, that can be easily repaired. Even if you want to replace any particular element of a system, that can be done easily with the help of this demountable concrete system. So here in the same figure, we can see how the construction process can be carried out and how the deconstruction process can be carried out. So from 6 to 1, we can see the construction process. So we have the foundation, then we have the erection of the columns, then we have the erection of the first floor beams, then we have the erection of slabs, then we have the erection of the second floor beams, then we have the erection of the second floor slabs. So this is how the process can be in order to erect the demountable system. Similarly, if you come from 1 to 6, we can see how the systems can be demounted easily. So this is the process. If you look at from 1 to 6, we can see the deconstruction process also. And as I said, so the replaceability scenario, if you want to replace any particular element of the system, it is very easy to do in the case of the demountable systems. So you can see here some of the damaged beams. So in the case of damaged beams, what you can do is you can replace these damaged beams by providing some supports or temporary shores. So first floor floors, so we have to support the slabs with the help of some shores, and we have to remove the beams and it can be replaced by the new beams. So that is possible with the help of this newly developed system. And so this is the process which I have explained. So first we have to temporarily support the first floor slabs. Then connections between the damaged beams, floor slabs and the columns are unbolted. So that is the next step. Then we have to remove the damaged beams by crane. Then erection of new beams of the same size and connection configuration as the damaged ones. Then connection of the new beams to the columns and the slabs. Then removal of the temporary shores. So that can also be done easily with the help of this demountable system. So it is nothing but, so in steel structures, normally we have some connections between the beam and column. The same type of connections we can employ for the concrete systems also, so that instead of demolition, so we can go for replacing any structural element or a part. Or if you want to even upgrade the system, so that is possible with the help of this demountable connections. So similarly, we can add the steel braces also to the existing system in order to improve the lateral load resisting capacity. So this is very easy in this case because the addition of steel braces, it is not so tough because in the existing beam column connections itself, we have the gusset plates. So to which we can easily add the steel braces to the existing system. So these are the new braces which are attached to the existing system. So that is also possible in the case of, in terms of upgradability of the existing system. So that can be easily done with the help of this. So coming to the merits of this demountable concrete system. So as said earlier, like it is very sustainable. So instead of demolishing the entire system, so we can do it, which lead to reduce the use of materials, consumption of materials, and also reduced energy consumption. So all these energy savings are there, and also the base reduction reduction of waste is possible, and it can be easily demountable. And no cast in situ concrete, no formwork is required actually. So fast erection due to dry connections, then reduction in the project to overhead cost. So that is also possible with the help of this demountable concrete building system. And the system is very simple. In fact, actually, no specialist knowledge is required in the design and construction. So if you are familiar with the connections between the steel structural elements, the same type of connections can be employed here also for connecting the concrete structural elements. So that is the thing. So easily demountable and easily upgradable and easy to repair and replace also. It is possible to replace the frame elements with the new ones. So these are some of the merits. And of course, we have some challenges also, especially after a disaster or after an earthquake. So if you want to replace the damaged beams in the upper stories, then a little bit difficulty will be there in case of for demounting as well as the replacing the damaged beams. And especially the practicality of replacing the damaged column base in fixed base, seismic frames after an earthquake. So this is also a challenge for us, especially we have the fixed base connections. So we have some difficulties in replacing the damaged columns also. So that is one of the challenge we have. The lack of design guidelines, as I said, so this is only in the research stage. So you can see only limited papers are there in this particular topic. So definitely a lot of scope is there in this particular area where we can do a lot of experiments and we can try to develop some design guidelines for this demountable concrete building systems. And another challenge is that challenge in extending the proposed demountable system to buildings with RC shear walls. So that is also one of the challenges which are identified in this demountable concrete building system. So these are the references. So if you see the references, actually, if you refer so most of the works were done by the University of Bradford, UK. So there are a lot of scholars are doing research in this particular topic. So definitely those research papers, you can take it as a guideline and you can extend further research work on this particular area. So we have only limited literatures in this particular topics. It is certainly an interesting topic. So if you are really interested in this particular research area, you can have a focus on this and you can develop more on this particular research area. So that's all from my side. If you have any questions. If you have any doubts.